Welcome to Creative World. In this video, we will solve Chapter 3, Exercise Problem number 3.3. While solving this problem, we will be using Kirchhoff's current law. According to this law, sum of all entering currents on a node inside an electrical network is always equal to sum of all leaving currents from that node. Now, move towards the problem. Exercise problem number 3.3. Find the value of current I0 in given below figure. This is the circuit diagram of given problem. Inside this network, we have to find the value of current through this branch labeled as I0 with this specific direction. So without wasting time, let's proceed towards the solution of the network. In order to solve this network, we will apply Kirchhoff's current law. First of all, we will apply Kirchhoff's current law on this node to calculate the value of current through this branch. On this node, one current is entering 6 milliampere and one current is leaving 2 milliampere. So remaining current should leave from this branch in order to justify Kirchhoff's current law on this node. Because we know that sum of all entering currents should be equal to sum of all leaving currents. Right now 6 milliampere current is entering but only 2 milliampere current is leaving. So rest of current should also leave from this node. So the direction of current through this branch will be leaving from this node, and KCL equation on this node will be sum of all entering currents. In this case only one current is entering 6 milliampere minus sum of all leaving currents. In this case 2 milliampere and current through this 1 kilo ohm resistance, both are leaving from this node. So both leaving currents are taken with negative sign while entering current is taken with positive sign. Now we are interested to calculate the value of current I 1 kilo ohm. So place it on the other hand side of equal and subtract 2 milliampere from 6 milliampere. So the value of current through this 1 kilo ohm resistance will be 4 milliampere. This 4 milliampere current will be leaving from this node. Now we will apply Kirchhoff's current law on this node to calculate the value of current through this branch. On this node, two currents are leaving. One is 6 milliampere and other one is 4 milliampere. So in order to justify Kirchhoff's current law on this node, one current should at least enter on this node. That entering current should be from this 2 kilo ohm resistance. So we can say that current through this 2 kilo ohm resistance will be entering towards this node. Now write KCL equation for this particular node. On this node only one current is entering, that is current through this 2 kilo ohm resistance. It is taken with positive sign while leaving currents are taken with negative signs, 6 milliampere and 4 milliampere. Now sum up these two currents and place them on the other hand side of equal to calculate the value of current through this 2 kilo ohm resistance, that will become 10 milliampere. So 10 milliampere current is passing through this 2 kilo ohm resistance and it is entering towards this node. Now we will apply Kirchhoff's current law on this node to calculate the value of current I0. On this node only one current is entering, that is 4 milliampere, while two currents are leaving. Leaving currents are taken with negative sign. One current is I0 and other one is 10 milliampere. In order to calculate the value of current I0, place it on the other hand side of equal and subtract 4 milliampere from 10 milliampere. The answer will be minus 6 milliampere. Now here minus sign is indicating that the direction of current I0 taken inside this network is wrong. The actual direction of current through this branch is upward direction, opposite to the given direction. So the value of current I0 through this branch will be equal to minus 6 milliampere. This was exercise problem number 3.3. Thank you. See you again in next video.